Very good morning, students. Today, I'm going to discuss about design and analysis of algorithm. Topic all about the mathematical equation for the recurrence relations. Okay, recurrent relations. The first one having is algorithms are the definition of the function of n. Having the if n greater than or equal to zero, print n. Then having the f equal to n minus one. For this loop will be executing by n time. So it is having that is a n time. The once the n greater than or equal to zeros are there, this loop will be executing by one time. This loop will be executing by n minus one. So we write from as the entire equation from as the particular equation for that. T of n equal to when having the n equal to zero mean give written by one. Otherwise n equal to not equal to zero give by the t of n by n minus one plus n time. We can call by the tree method also we can able to track. Okay, for the tree method you can track by function equal to 4. When having the n equal to 4, first I have to print by the 4. After having the n minus 1 equal to 3, 4 minus 1 equal to 3. After having there is a 3 will be there, 3 going to print on there. When having there is 3 greater than equal to 0, condition will be true. Then having the function equal to 3 minus 2 equal to 3 minus 1 equal to 2. After having the print with the 2, having there is a 2 minus 1 equal to 1. Again print with 1. When having the function equal to 1 minus 1 equal to 0, that time condition will terminate for that. Totally executing by the 4, 3, 2, 1, 2, 1, 0. Totally 5 times going to execute it. Totally having the what is the n value equal to 4, n plus 1 going to execute. Totally already the n value for the 4 time going to execute. Total number of computation when there is a order complexity compromise the big O of n. We can able to solve by the same equation through by as the recurrence relations also. Okay, for recurrence relation, we have to call by the what is the inside loops are they. Inside loop having it is the t of n minus 1 plus 1s are they. So written by the when having n equal to 0 means they it written by the 1. T of n minus 1 plus 1 equal to when having n equal to 0, n equal to greater than equal to 0. For we can write from the equation equal to we don't know what is we don't know that is what is n minus 1, but we know that is a t of n value. T of n value equal to t of n minus 1 plus 1. So we can written by the t of n minus 1 we can able to find when written by the t of n minus 1 we have to replace from as the n we got the value equal to n, so we have to replace from the n equal to n minus 1 value for that. So we got from as the t of we have it is the n equal to t of n minus 1 plus 1. So we can written by there is a t of n we can replace from this n minus 1. So it is minus 1 equal to n minus 2 will be there. N minus 2 will be replaced by here to we got from the second equation number 2. Okay, similarly we can able to find on this second equation on by the see, the n minus 2. We want to find the n minus 2 value. We had substituted by there is a n minus 2 equal to we got the value equal to this n minus 2 equation substituting on by here we got by n minus 3, n minus 2 minus 1 equal to minus 3. So we got from this the t of n minus 3 plus 1. We got the equation for that. This particular k value, this particular the equation go from as up to k time. So we written by the t of n minus k. So it will go from as the k time now. So we write from as the k time value for that. So we written by the go for this n time for the n time having that is substituting the value. Suppose here we having the third equation substituting on second equation for the third equation is that written by third equation t of n minus n minus 2. Suppose we are substituting by the after finding by the 1 to 3 equation, substituting by third equation in second equation for the t of n minus 1 equal to t of n minus 2 plus 1. So t of n minus 2 if we can find the value equal to t of n minus 3 plus 1, n minus 3 plus 1. So already having plus 1s are there, so written by the equal to t of n minus 3 plus 2. We got the equation number 4 for that 4. This compromise the fourth equation. After find the fourth equation, substituting by the fourth equation in the equation number 1. This become as the t of n minus 1. So t of n minus 1. So fourth equation, first equation for that. For substituting the fourth equation, first equation, we got the value equal to t of n equal to t of n minus 1 plus 1. Okay, t of n minus 1 and plus 1. For that we got the value equal to t of n minus 3 plus 2. Then this plus 1 we have to add. So we got the value equal to t of n minus 3 plus 3. This become as the equation number 5. Okay, for this particular the t of n value go to the k time 1, k times 1. So we replace from as the k value. So t of n minus k plus k. So for that we had to replace the equation. So we got this value from here. So we had to continue from as it is a k time. We got the value for that. Okay, t of n equal to t of n minus k and minus 1s are there. So minus k's are there. For replace that one, we have to replace the first equation for that. We got the value now. First we had written by t of n equal to 1. So this t of 0 equal to 1 now. So we have to replace by the n minus k value. N minus k value replaced by 0. So k equal to n. So the k value replaced by n here. K value replaced by n. T of n minus to n here. We got the value. Okay, we got the value is that okay t of n minus n. So we got the value t of 0. T of 0 means is a 1. So it is a 1. That means the n will be replaced. So we got the complexity is the big O of n. This having the big O of n. That means the time complexity of the order of n. We can find the answer for that. So we can find the value equal to order of n. So this is also computed from the recurrence relation. This is also computed from as the train method. Both are equal for that. So go to the second problem for that. Okay, we have to find. Okay, we have to find some other in the exam point of view. Some other equations are given by here. Recurrence relations are given. From the equation, we can able to find what time complexity for that. Time complexity calculation process. We have to give the equation equal to t of n. T of n equal to n minus 1 plus n greater than or equal to 0. The t of n equal to 0 means written by 1. This loop will be executing by the up to one time had to computed. Okay, up to one time. That means as the what will be given by the n value, the subtracting the method up to one. So here where the term from is the t of 0 equal to 1. This is important. Substituting the equation for the third equation. For here as the first equations are there, second equation, third equation we can find. When I find the fourth equation, third equation substituting on the second equation I got from as the fourth equation for that. After find the fourth equation substituting with having the first equation we got by the fifth equation for that. After the fifth equation we can replace from as the k value for that. After the k values are there, k value replace, we have to replace from this particular the term. We have to what is the brackets are there, we have to replace by this particular term for that. We can able to find the time complexity very easily for that. For here, first I had to compute it from was the equation number 1. Okay, equation number 1, we got the value equal to f n equal to n minus 1 minus n. So I have to n replace from as n minus 1. So n have to replace by n minus 1. Here also having n minus 1, here also n minus 1, replace it. We have to compromise the t of n minus 2 plus n minus 1, compromise the equation number 2. From here, t of n minus 1, we have to replace from this n. First I replace by n minus 1, after replace by n minus 2. After replaced by n minus 2, we fought here n minus 2 minus 1 equal to minus 3 plus n minus 2 sadi. So we got the equation once 1, 2, 3. Third equation substituting by second equation for that means the t of n equal to t of n minus 2 plus n minus 1. For this equation, t of n minus 2 value is replaced by this equation value for that. So t of n minus 3 equal to plus n minus 2, 1 we got the value plus n minus 1 I had replaced n minus 1. After replaced by here, we had taken outside the bracket loop. So we got from the t of n minus 3 equal to n into n having 2n plus 2 minus 2 and minus 1 become as a minus 3 for we got the fourth equation for that. Substituting the fourth equation, the first equation for that, t of n equal to t of n minus 1 plus n are there. So we got that is the n minus 1, we can find the value equal to t of n minus 1 is this equation. So replace the equation for that. T of n minus 3 plus 2n minus 3 plus n. So we got the extra one n is there. So I have to add from here 3 n's are there. So here we got the value equal to t of n minus 3 equal to 3n minus 3 are there. We got the value n minus 3. That means we had to replace from the k time or replace from here. T of n equal to t of n minus k plus 3n minus k will be there. Wherever three constants are, I had to replace from this k value for that. We got the value equal to 0. So inside value equal to n minus k equal to 0, n equal to k. So t of n equal to t of n minus k. At t of n minus k, we have to replace that equation for that. T of n minus 1, we have to replace that equations. First, I have to replace the equation into the n minus k equal to 0, k equal to n. So, t of n minus n equal to n into n plus n. So, this equation becomes as a 1, n into n becomes n square plus n. So, our output equal to, that is the t of n value equal to, that is a n squared plus n. So the highest order is the big O of n squared 1. So this particular equation time complexity is the big O of n square. Next example compromise x of n equal to x of n minus 1 plus y n greater than equal to 0. This becomes as n equal to 0 for that. So first equation replace from as the plus 1. Then the n replaced by the x equal to x equal to n minus 1 plus y. N replaced by the n minus 1. So n minus 1 into minus 1 because the n minus 2 plus y. Here n minus 2 replaced from here, minus 1 be added, n minus 3 plus 5 are there. Third, we are substituting on the second equation, we got the value equal to x minus 2 plus 5. X minus 2 replaced from this particular equation for that. This equation become as a plus 5 want to add it. So x of n minus 3 plus 10 we can got from the fourth equation for that. After finding this equation, substituting on the first equation for that. This equation substituting on the first equation by here because this is a x of n minus 1. This become as a x of n minus 1. Fourth equation substituting by first equation x of n minus 1 plus 5 are the x of n minus 3 you can find from as x of n minus 3 plus 10 for the plus 5. So 15s are coming output. So here by the 15 is written by the 5 into 3. So written by the 5 multiply with 3. So we got the constant value here 3 3. So we have to replace the value equal to k value or replace it. So n minus k plus 5k. N minus k plus 5k will be there. T of n minus k. For n minus k written by the 1, so k equal to n minus 1. So I have to replace from this k value equal to n minus 1, here also k value equal to replace by n minus 1. This have to n minus 1, n minus 1. No, this both n going to be cancelled. We got from as it is a 1 only. That means the t of 1 value equal to 1. T of value equal to 1 for that. This 5 into n minus 1 we had replaced now because k value replaced by 1. 5n plus 5. 5 and minus 5 is are there. So total number of the time complexity is the highest order become as it is a 5n only. So we can write from as that this suppose consider with this also minus 1 mean we can write from as the 5n then having the minus 6 are there. We got the highest time complexity come from as the n only. We got from as the order of n. The same recurrence relation we have to calculating by the master theorem also. The master theorem we have to solve the method. Here when there is a master theorem are there x t of n equal to then alpha power t into n minus b into n to the power k will be there. Here alpha value greater than equal to 1, beta value is greater than equal to 0, k greater than equal to 0. For these cases are available, the three cases are available. When having the alpha value equal to 1, alpha value less than 1, greater than 1 are there. Suppose alpha value less than 1 are there, theta big O of k n to the power k is there. Alpha value equal to 1 mean the big O of k n to the power k plus 1 are there. Alpha greater than 1 equal to alpha power n to the power k and alpha power n by b is there. First substituting by the first equation for that x of n value, x of n minus 1 plus 5 only. Plus 5 mean 5 to the power value equal to 1 only. Then only correct answer. For this means that if without having any statements are there x equal alpha equal to 1, then having the beta value is not considered by the any symbol over there. Any symbol not consider, only consider by this symbol only. So it become as a 1 for the k value equal to 0 for the. Here k value become as it is a k value equal to is a 1. Suppose consider by here k value equal to 5 to the power of 1 no? So written by the 5 k value equal to 1. So alpha value equal to 1 no? So alpha value equal to 1 mean we consider by this condition for that. Okay, we consider by this condition 5 to the power of here n to the power k only required now, so it won't come this value. This come from 0 only, so it can compromise the n to the power of k because there is no n, only constant values are there. Suppose n is there, you can able to consider 5 n's are there or n is the consider. Now k value equal to 0 for that, so it is having it is a compromise a case 2 because alpha value equal to 1 that become as a case 2 because of n because n to the power k plus 1, k value equal to 0 plus 1, 0 plus 1 equal to 1. So the time complexity is the big O of n. Then I come from this particular statement, there is no term from as the k, so automatically plus n to the power k not available, so it is alpha value equal to 3, then beta value b value equal to 1. So come from as the case as the alpha value greater than equal to 1, so it become as the third case for that big O of n to the k equal to 0, then having 3 to the power of alpha is 3, the n by b value equal to 1, so 3n. So here having there is a 1 become as the big O of n squared. When I compromise x of n equal to x of n minus 1 plus n into n minus 1. For this statement written by the n squared plus 1. So if you want to replace the equation x into n minus 1 plus n squared plus 1. So I written the statement equal to return statement equal to n. So we are replaced from here the alpha value equal to 1, the beta value equal to 1, the k value equal to 2 for the k value equal to 2 for that. Compromise the equation is the first equation only. I have to compromise the equation number 2, case number 2. So it's alpha from as the k value equal to 2 plus 1 equal to 3. So I become as output equal to big O of n to the power of q. Thank you for watching my channel. Subscribe my channel. Okay.